Okay, so you're gonna start experiment 6 lab next week or this week. So the experiment 6, the topic is electrochemistry. So before we do this lab, you need to know a couple concepts. One is called the galvanic cell. Okay. Galvanic cell is the cell that the current goes through from the spontaneous reaction from the two metals, okay? And then the one we use, the metal is we use the copper, zinc, iron, lead, and silver, okay? I'm gonna show you how to draw the galvanic cell using copper and zinc, okay? Everybody need to draw, okay, on the final exam and the quiz in the future. So I want you to really study about this, okay? So first, the galvanic cell, you need to have the two metal solutions. So we have a copper and zinc. So I'm just gonna write it the copper here, zinc. And then you need to put the metals. So this one is a zinc bar, and this one is a copper, okay? And then both of them has to be connected to the voltmeter. We're gonna use the pH meter in the lab to measure the cell potential, okay? And then one more thing need to be drawn in this galvanic cell. Do you have any idea? Which is, it's called a salt bridge. I will explain why we need a salt bridge in a minute. Okay, so I will explain how the current goes through. So the copper, so it's gonna be the spontaneous redox reaction between copper and zinc, and then you need to know which one is gonna be the reduction reaction and which one will be the oxidation reaction. Okay, to determine that, you need to look at the reduction potential table, which is page 127, okay? And then you look at, you can find, this is all reduction reaction, and then you need to pick the reaction for the copper and zinc. And then I will pick up for you. So the copper, 2 plus, react with a 2 electron, becomes copper metals. Okay, that has the potential is, this is the standard cell potential, and then this one is a positive 0.34. Okay, and the next one is the zinc. So the zinc is, so zinc also positively 2 charge and plus 2E minus, and then it becomes the zinc metal. Okay, that one is negative 0.76 volts. Okay, and then if you look at here, first I want you to look at the standard cell potential. Okay, maybe you learned this already in the lecture, but I will explain what I learned. Okay, so so you compare the cell potential, whichever is lower than the other, you're gonna flip the reaction. Okay, so if you look at those two potential, this one is positively 0.34, this one is a negative 0.76. So this cell potential is lower than the other. So this reaction is gonna be flipped. So the zinc should be zinc solid, the middle bar, it's gonna be the zinc solution, and then okay, and then this cell potential is gonna be, this side is gonna be flipped. So the total redox reaction, you just add them together, and also the total cell potential, you just add them together as well. Okay, so the redox reaction for the copper and zinc is gonna be zinc solid plus copper solution, and then the electron is gonna be cancelled. Both of them are 2 electrons, and it's gonna be zinc and copper. Okay, and the E standard cell potential, the whole cell is gonna be add them together. So the copper is 0.34 plus 0.76. It's gonna be 1.1 volt. Okay, that's how you calculate the E naught. Okay, and then so which one? So if you look at this one, so the zinc is gonna be from zinc is the one that release the electron. Okay, so the electron flow is gonna be from zinc to copper. Okay, and then the this one is oxidized, so this one is oxidation. This one is reduced, positively 2 charge to the 0, so this one is reduction reaction. So here is oxidation and then reduction. And then the galvanic cell, the one that are oxidized is called the anode. Okay? And the cell is reduced is called cathode. The way you remember is that you can remember as alphabetical order. So like A comes before C, right? A, B, C. And then O also comes before R, so O, P, Q, R. Okay, so that's the combination. So like oxidation is anode and the reduction is cathode. Okay? So what's gonna happen to the zinc and copper? So if you look at this one, so the zinc bar is gonna release the electron and then becomes the zinc solution. That means this metal bar is gonna be thinner and thinner. It's gonna be smaller, okay? And then this positively charged is gonna be built up a lot, okay? But on the other hand, the copper solution is gonna be used, okay, gain the electron becomes the copper bar. So it's gonna be, this one is gonna be thicker, okay? So that means this solution is gonna lose lots of positively charged, okay? So the salt bridge, the reason why we put the salt bridge, so for us we use the KNO3. So since the zinc is gaining lots of positively charged, to maintain the ionic strength, the negatively charged ion need to go here, okay? And then the copper, since they losing the positively charged ion, this K plus positively charged ion goes there. That's the reason we put the salt bridge, okay? So I want you to study this galvanic cell and then also the calculation from the standard E cell.